All right. On that note, I bid everyone good night, and I'll get some pictures out to a few colleagues, but when I get back, hopefully I'll do a full report and show you some home movies. All right. See you later, guys.
Thanks, Angela. Have a great trip.
No worries.
Keep us updated. We're now going to flip over to Malcolm Jarmyn, and he's going to give us a talk about the Jarmyn space project. And I'll let Ashley do the configuration switch. Just go ahead and unmute yourself, Malcolm, and share your screen, and you're good to go.
Cool, thank you. Hang on. That one. Oh, come on. Let's start. Hi everyone, I'm Malcolm Jarmyn, CEO and founder of Jarmyn Enterprise Space. I've been on here a few times with you guys, and just giving you an update on our work and a bit of a rundown on the company itself. Originally it started, the idea came back in 2004 roughly, when I first saw Virgin Galactica do their test flights before it became Virgin Galactica. And I thought to myself, if they can put 12 people up to space, why can't you put half a ton of material up in space? And someone jokingly said, why don't you design the craft? So I started working on an idea of the Stingray space plane. I was in defence at that time, and I got in touch with a few people, and they said, well, there's no engine out there that can do it, so you're going to have to come up with a new engine. So I started doing some research. Not being an engineer, I had no real idea. And through some contacts, I started working on the JSX1 hybrid engine that I was working on. I got in touch with some people, and they kept telling me I had to go back to basics. The engine was too complex for me. So I kept going back, and over that time, I registered as a company to get a bit more support. And that's in my endeavours to make it the basic engine. The Swift engine came around, which is the Methalox engine that we currently have in manufactured. But in 2020, I registered as a company to get a bit more support on that, and I got a few team on board to help us. And the Hawk Junior vehicle came into concept as well. We worked on the engine. We thought, well, we've got an engine now. What are we going to do with it? So we started working on the concept of the Hawk Junior single stage to orbit launch vehicle. This started developing, but we had a few staff changes over the last year or two, and new guys came in and said, we're not ready for a single stage to orbit launch vehicle. So we've not gotten rid of the idea. We've put it on hold until we perfect our technology. So now we have the Hawk series of launch vehicles, which I will be talking through tonight. So our goal is to put payloads into orbit safely and affordably for commercial, exploration, research, tourism, mining, and eventually to live. Everyone, I'm sure everyone wants to live in space one time or another. And we're doing this through development of the technology one step at a time. Every day we're learning new technology that's out there. So at the moment, we're working on a payload of about 250 kilos that we can put in, which is a lot more than we were working on with the SSTO. And this because it's a two-stage vehicle. So at the moment in the market, you've got 3 lanes. Your 1 to 20 kilo satellites, 20 to 500, and then the 500 plus. We're working on the first 2 lanes for customers and payloads. And we're still working on accurate satellite deployment. So instead of being a bus and kicking the satellites out wherever, and the satellites have to make their own way, we're actually looking at putting the satellites in their locations, so the satellite companies don't have to carry that extra fuel to move the satellites into position. We put them in position, and they're just going to do the final little bits to get it right. And we can do ride sharing if need be. So our solution is the Hawk series of vehicles: the Hawk sounding rocket, the wagtail, and the wedgetail. The sounding rocket is, oh pardon me, a single stage high altitude rocket with 1 engine on it. The wagtail is 2-stage and it will have 9 Wren engines on it. And the wedgetail and albatross, which are in development, the wedgetail will have 9 Swift engines on it and it'll be 2-stage. The albatross is still in concept at the moment. The sounding rocket is about 300mm diameter, 5 meters high, 1800 fully loaded, and we're working on about a 20-kilo payload on it, and it's 1-stage. The wagtail, 2-stage, 250-kilo payload, 1 meter diameter, 13 meters height, total wet mass of 1700 kilos, and it's got 9 Wren engines on it. And the wedgetail, expendable, 7,500 kilos, reusable. Our vehicles will all be reusable. The reusable one, 1,500 kilo payload. That's just because of the all the extra bits we've got to put in to bring the vehicles back. 3 meter diameter, 39 meters high, and 250 ton of total mass, wet mass. And it's powered by 9 Swift engines, and it's 3-stage. At the moment, we're partnered up with a few companies, and we've got already letters of intent. Our team, we've got myself, Julian, who's involved with it. At the moment, he's helping, but he's had to step back for a little while. AJ's head engineer. Adam's now stepped up to our head of propulsion engineer. Roger's working on avionics. Katik's on avionics as well. Bella, a graphic designer and web designer. Amit is our business officer in India. Abhishek is our grants liaison, and he's doing a few other bits and pieces for us as well in the administration side on that. And we've got Michael Siddell, who's our ICT guy. April stands our additive manufacturing engineer, and she's just been on LinkedIn. She's in Melbourne, and she's in a group over there called Girl Geeks. They've just done a big stand over there for encouraging high school girls to get interested in STEM. We actually had one of our model engines there on the stand as well. These are, that's actually a Swift engine. Where's the Wren engine? Okay, that's the Swift engine. We did have, hang on, I'm trying to find, there's the Wren engine, sorry. Okay, that's the Wren engine for the sounding rocket and the wagtail. It's additive manufactured, and we're looking at most of it being made of copper. As you can see, specific impulse vacuum of 347 at sea level, 325. It's Methalox. We're looking at electric fuel pumps for it, but the sounding rocket initially will be pressure fed for testing. We're still developing our own electric fuel pumps for it. It's all optimized plumbing and, as I said, 3D printed. We're also possibly looking at another technology that I won't go into about the manufacturing of it until we're fully sure it will work. The Swift engine, specific impulse at the moment, it's still in design. We don't know the full power of it. It's Methalox. It's a full flow staged propulsion system. So turbo pumps, Adam's having a lot of fun designing them up, and we're trying to find the suitable materials for the oxygen turbines, because it's high temperature and full oxygen environment. Standard materials just won't tolerate it. Just a rough outline of our sounding rocket design. It's pretty basic: fuel tanks, avionics, payload. It's lightweight, full recovery system, and trying to make it as reliable as we can. The avionics for the systems is an Australian company that's providing it for us as well. The wagtail, 2-stage, your first stage with your fuel tanks, engines. Second stage is a Wren engine, but adjusted for vacuum environment, so a larger nozzle on it. And then you've got your avionics bay and payloads bay. With everything for this will be manufactured in Australia, and payloads come from whoever wants to use our systems that are allowed to. We're also in the process of developing our own engine test facility in South Australia. We have discussions with the Queensland test facility that's being developed as well. So we've got a location for our test site. We're just going through the all the red tapes go with it from the government departments and that. But once that's running, it'll be a certified engine test site, as long as the landowner lets us use it. This is just a comparison of our vehicles. As you can see, your Falcon Heavy, don't think we've actually got they're about the same height as your Falcon 9, I think. So it's not much smaller than a Falcon 9, like wedge tail. So this is just our suborbital launch of the sounding rocket. Goes up to about 105 kilometers and then we'll parachute down. We'll be able to recover it and do full analysis of the system. This is to test and verify our engine, validate the avionics and everything, and all the guidance systems and that. Once that's all successful, two-stage vehicle is meant to, we've got to adjust this design, where the nozzle jettisons, roughly, the first stage will return similar to a Falcon 9 booster with the engines and a gentle descent. We're still working on the finer details of how that will work, but the second stage will continue up, deploy its payload, and then a balloon will deploy around it, enveloping the whole vehicle, creating a drag which will slow it down on re-entry. And as it gets to a set height, the balloon will deflate and the engines will assist to land on land. If that's not successful, the balloon can stay fully encapsulated in the vehicle and it can splash down in sea, protecting the whole vehicle from seawater. These are our current launch sites in Australia. We've got Southern Launch in South Australia, Space Centre in Weipa, South Queensland, Western WA Spaceport in Albury, Western Australia, and ELA out at Gove in Northern Territory. Just a map to show where they all are. Our future company expansion that's in discussions at the moment is setting up, expanding into India, into Wales, and USA. Our future concepts, the Stingray spaceplane, which is in the background, slowly being worked on at the moment. The augmented engine that goes with that. It's a hybrid turbofan jet engine that can be used for putting craft into space. With those two successfully achieved, we then put a construction yard in orbit to start manufacturing large vehicles in space. The other one that we're toying with the idea at the moment is putting the wedge tail heavy with a manned capsule on top. We believe we'll be able to do it, have a 3-man capsule on top that'll be able to lift it. So having a manned launch from Australia would be amazing. And that's roughly all I've got at the moment, as launching payloads into space affordably and safely. Okay.
Thanks, Mel. That's fascinating. We might open up to the floor for anyone who's got any questions. I've got a few myself, but anyone in the room here, put your hand up or come up here and ask a question? Well, my question, I'll start off. Have you had any interactions or support from the Australian Space Agency at this point?
They've had shown some interest, but we haven't had much from them yet. Julian was in discussions with them for the licenses and everything. And that, do you want to add anything, Julian?
Yeah, sorry, I didn't realize I can unmute. Yeah, we started initial discussions with the regulators and Safe Work, Safe Australia, because we just can't go in the backyard and test fire an engine. But so far, things are looking good, and we've got a healthy relationship with the regulators. So yeah, we're through the application process to allow us to test fire.
So is that within South Australia? Is that the federal? Is that the federal government or the agency, or what? Who's the
It's actually a combination of all government bodies. Because of the engine test site, we've got to go through local government, and then state government for safety and that, and then the federal government to have their final say on it.
And once we start launching, then other departments such as CASA jump on board. But for the initial stages of test firing, it's just all your local all your regulatory governing bodies like Safe Work, Safe Australia.
So one of your slides there showed an engine firing. Was that one of your test firings of your own engine, or is it?
No, that's one from someone else.
Okay.
I'll just see if.
So have you fired up an engine at this stage yet, Malcolm, or is
No,
still?
no. We've only just finished getting the prototype engine made. It had to be the printing method we used had shrinkage in the components, so it needed a lot of machining, and it took me a long time to drill out 61mm holes.
Right. Okay.
But it's all welded together now. We're just in the process of waiting on the BOC fuel to come along. They're doing all the fuel lines and valves and everything for it for the test site. And then they'll with them Safe Work SA supervising the engine test site development. It'll make sure it'll meet state and federal regulations. And once they all sign off on it, then we'll have an engine test facility in South Australia for rocket engines.
Fantastic. Very good. Well, thank you, Malcolm, for joining us, and Julian as well. Obviously, you've still got a lot of work to do and a lot of water under the bridge, so maybe we can get you back in 6 or 12 months and give us an update on your progress. And obviously, we can point people to your website if they want to get involved, or just keep an eye on what you're doing. We'll put links in the chat if people are online to do that. Thanks, gentlemen. Have a great evening. And please stay around, and we might be able to have some more questions at the end of the meeting if you want.
Yep, no worries.
Thanks, Julian.
So if there's anyone online who does want to ask a question now, just quickly unmute yourself and ask the question. No? Okay. All right, thanks again. And we'll go back to the rest of the meeting. And once again, guys, please be more than welcome to stay online and we'll join up at the end.
Thank you. Thanks for the opportunity to present.
That's great. Well done. Thanks.